which converts the analog voltage into digital voltage. So if the input keeps on fluctuating, then it is not knowing which voltage to be converted into digital. That is why when input is fluctuating, we will sample that voltage, and that voltage will convert it into digital. So somebody has to sample and hold it. Somebody has to sample and hold it. So sample and hold circuit, you have a switch and a capacitor. In the sample and hold circuit, you have a switch and capacitor. So whenever I want to sample this, I will close this switch. Then my electrolytic capacitor will maintain that voltage. After some time I want to sample again, then I will close this switch, then my capacitor will hold. So sample and hold circuit is a switch and a capacitor. Maybe you can use a buffer. So at the input you have switch, that switch is a MOSFET, then capacitor, then a buffer, op-amp buffer. Peak detector. So whatever you see in electronics is a repetition of what you have already studied. For example, low pass filter, you have already studied RC circuit, one op-amp is added. Is it not? Integrator, you have already studied RC circuit, one op-amp is added. So that I get all the benefits of op-amp. Benefits of op-amp: high input resistance, high gain, low output resistance. Those benefits I will be getting. So if I have a rectifier with a capacitor filter, you have studied in electronics. If you I think you can get out of this room. You both are talking. Please leave the hall. You leave the hall. So you have studied, if you have a rectifier with a capacitor filter, the capacitor will be charged to the peak value. You have a rectifier with a capacitor at the output, then the capacitor will be charged to the peak value. This is what you studied in measurements. In measurements you have something called peak reading instrument. In peak reading instrument, the capacitor will be charged to the peak value. So I have a diode rectifier, then I have a capacitor, then the capacitor will be charged to the peak value. That's why it is called peak detector. So if I keep one op-amp based rectifier and then capacitor filter, then that will be charged to the peak. Next you have studied the oscillators. So amplifiers you have studied, oscillators you have studied. In the oscillators you need one amplifier. Oscillator is a positive feedback amplifier. You will have one amplifier and one network. That amplifier you can go for op-amp. So Barkhasan says an oscillator will work if total phase shift is 360 degrees. Closed loop gain must be 1 and loop phase shift must be 360 degrees. So 180 degrees I am getting from the op-amp because I am using an inverting op-amp. So this inverting op-amp I am getting 180 degrees with this. And each section, I have 3 RC sections, each section gives 60 degrees, so 3 into 60, 180. So this gives 180 and this gives 180 and total phase shift is 360 degrees. So if you have an op-amp, if this gives 180 and this gives 180, total phase shift 360 degrees, then output and input will be in phase. 360 degrees is same as 0 degrees. So you are using 3 RC sections to get that 180 degrees phase shift, and you are using one inverting amplifier. So this is op-amp based RC phase shift oscillator. So the analysis shows that the gain must be 29. Beta is 1 by 29, so gain must be 29. So if gain is 29, beta is 1 by 29, A into beta will be 1. That is the condition for producing oscillations. Next you have mean bridge oscillator. So in mean bridge oscillator you have that RC section and you have your op-amp. You are giving both positive feedback and negative feedback, but positive feedback will be made higher than the negative feedback. Ultimately oscillator is positive feedback amplifier. Oscillator is positive feedback amplifier. So in this I have both positive feedback and negative feedback, but I will make positive feedback to be more than the negative feedback. So I have a Wien bridge, and that is Wien bridge oscillator. So sometime back we were talking about instruments, CRO and multimeter, two popular instruments. If one is your brain, other one is your heart. So without CRO and without multimeter you cannot live. So in that you have an amplifier at the input side. At the input of your multimeter there is an amplifier. At the input of CRO there is an amplifier. So what is that instrumentation amplifier? Instrumentation amplifier has a buffer in each line. Then I have a difference amplifier. So this whole thing is fabricated as one single IC. That single IC is available in the market. That single IC is instrumentation amplifier. So I am putting one buffer in each line. So student may make any type of mistake when they connect to the CRO or to the multimeter. CRO should not get damaged or multimeter should not get damaged. So to avoid the damage of CRO or multimeter, we are putting a buffer in each line, then a high gain amplifier. Next, voltage controlled oscillator, VCO. In a voltage controlled oscillator, frequency is proportional to the applied voltage. More voltage, more frequency, less voltage, less frequency. So given control signal is converted into a high frequency waveform, and frequency of that waveform is proportional to the input voltage. So initially the capacitor keeps charging. The moment the capacitor voltage goes more than 2.1, it will discharge through these diodes. Once it discharges, it comes to 0. Again the capacitor will be charging from the supply side. Then again it will discharge. So you get a triangular waveform, and the mathematical relation shows that frequency of this waveform is proportional to the input voltage. Why? How do you get that 2.1? How do you get that 2.1 volts? Breakdown voltage of cut-in voltage of each diode 0.7, 3 into 0.7. 3 diodes in series, 3 into 0.7. 2.1. So the moment capacitor voltage is more than 2.1, capacitor will discharge. Then again capacitor will charge from the input voltage, discharges. So you get a triangular waveform or sawtooth waveform. The frequency of that sawtooth waveform is proportional to the input voltage. So next we have to see what is PLL. In op-amp you will study PLL, phase locked loop. So before explaining phase locked loop, I will explain some other loops. You have a bike and you are driving that bike at 60 km/h. So your mind is telling you should go only at 60. So whenever speed is above 60, you reduce the acceleration. Whenever speed is below 60, your young blood is boiling, you increase the acceleration. So I assume that you drive in this road at a speed of 60 km/h, that is speed loop. Then at home in the refrigerator or in your AC, you have a set temperature. So in the night every day you are fixing the temperature to 20 degrees centigrade with your remote. So throughout the night one compressor is working. Whenever temperature is more than 20, compressor is on, takes the heat away from the room. Whenever it is equal to or less than 20, compressor is off. So you are sleeping nicely, but one temperature loop is working in your room. That is temperature loop. Like that, PLL is a frequency loop which is used in UPS. Because in UPS I want to maintain frequency. Using UPS I want to maintain frequency constant, equal to 50 Hz. So I have one set frequency and I have the actual frequency. I am giving it to a mixer. Mixer is an electronic circuit. It is a tuned amplifier with two wires available at the input. If I apply two signals to the two wires, the two currents get added. The two currents get added. So this is one signal V1 with a frequency F1. This is another signal V2 with a frequency F2. Then theory of mixer. Mixing means adding. If you add two frequencies, your mathematics says in the output you will have F1 plus F2 and F1 minus F2. So I am using a low pass filter. Low pass filter will pass the low frequency signal, that is F1 minus F2. So that is given to VCO. VCO, depending on the error signal, it will change the frequency, because in a VCO output frequency is proportional to the input voltage. So if I have more error, more voltage, then my frequency is updated until F1 and F2 are equal. Once F1 and F2 are equal, the updation stops. In a speed loop, the loop will make sure that actual speed is equal to set speed. In a temperature loop, actual temperature is made equal to set temperature. In a PLL, actual frequency is equal to set frequency. So when you are studying PLL, you will be studying three terms, namely free running state, then capture state, then locked state. The PLL has three states: free running state, then capture state, then locked state. Suppose if you don't give any signal here, it is called free running state. Once you give a signal, it will take some time for V2 to capture V2 to capture the frequency of V1. So it will take some time, frequency has to be updated. Then once F1 and F2 are equal, that is called locked state. One example in Indian marriage system. So when you are in final year, your father will say, I have seen a beautiful girl for you, so you will be getting engaged. Let us assume. So, and vice versa, it could be other way also. So you are in the beginning of the final year, your father says he has seen a beautiful girl for you, so you will be, until then you will be in free running state. From first year to third year you are in free running state. So once you are engaged, then you try to capture the heart of your would-be. So for 1 year you will be in capture state. Once you get married, according to Indian system, you have to get locked to the frequency of the spouse. Otherwise the life will be miserable. So the condition for locking, F1 is equal to F2. So your life before final year, during final year, after final year has three states: free running state, capture state, and then locked state. So like that, PLL has three states. So Malvino has two chapters, one on op-amp, other one applications of op-amp. Malvino is a wonderful author. He has two chapters. I want you to read Malvino first, then only go to any other textbook. Reading Malvino is as enjoying as eating sweets or watching a movie, because it is so simple. It is very simple. So I want you to read the two chapters of Malvino. Gaikwad is a standard textbook. So probably you can buy this Sarkar. Sarkar is good. Sarkar is a North Indian author, linear operational amplifiers. By Sarkar is a very easy book with all the problems. Malvino has only theory, no problems, but Sarkar has given problems. Raj Chaudhary is good. Salivahanan, any book of Salivahanan is tough. And Lal Kishore is a recent book which is also a standard book. But I personally feel that operational amplifiers by Sarkar is easy compared to any other book. So, stop.